Hi, Brandon Clayton here, the Algebra Guy. Today we are solving systems of equation using graphing. Now there's a number of ways you can solve a system, but we're going to focus on graphing in this lesson. So what teaks are we covering? Look at that, 3 teaks are being covered in this one lesson. It's a big one. So pay attention and let's get it. So graph systems of 2 linear equations, estimate graphically the solutions of systems, and solve systems of 2 linear equations with 2 variables using mathematical and real world problems. So jumping right into it, determine whether an ordered pair is a solution of a system or not. How do you know whether some ordered pair or coordinates are a solution? So when 2 or more linear equations are grouped together, they form a system of linear equations. Solutions of a systems of equations are the values of the variables that make all the equations true. So if you can plug in a point into that system and both equations are true from that particular point or ordered pair, however you want to call it, that's the solution. That's what we call a solution to a system. To determine if an ordered pair solution, you're going to substitute those values to see if those are true, which I just mentioned. For instance, here's an example. Is the ordered pair 3, 2 a solution to this system? So to figure that out, all we would need to do is plug in 3 in place of x and 2 in place of y. So I'm going to put my 3 here and 2 here. And then I'm going to put 3 here minus 2 times y here equals 4. So all I did, if you notice, in place of my x's I put a 3, in place of the y's I put a 2. So let's solve it and see if it's true for both. So if I did this first one right here, 3 times 3 is 9, 9 minus 2 is 7. So this does check out to be correct. What about this one? 3 minus 2 times 2. 2 times 2 is 4. So 3 minus 4 is negative 1. So this isn't correct. It said it should equal negative 4. I'm sorry, it should equal 4, but it's getting negative 1. So this is not correct. So it works for one but not the other. Is this a solution or not? No, it's not. Very good. Because it has to work for both for this system, because that's why it's called a system of equations. We want to make sure it works for both of them. What if I put 2, negative 1 in place? So let's try 2, negative 1 and see what we get. So 3, if I put a 2 here and then a negative 1 equals 7. And I put a 2 minus 2 and a negative 1 here. So let me just see if I wrote that correct, because I got these negatives that could throw you off. So I got that 2 minus 2 times a negative 1. Okay, so let's solve it and see. 3 times 2 is 6. 6 plus 1 is 7. So yep, that works, because this ends up being 6 plus 1. What about this one? This is 2. Negative 2 times negative 1 is a positive 2, so that's 2 plus 2, and this is 4. So both of these work out, so this would indeed be a system. So that's the big idea behind the system. As you see it graphically, what's going to happen is it's the point at which those 2 lines are crossing. That's the point that they share. All right, so if we solved it for this one, if we check for this one in practice, would these be systems? Well, I mean, would these be solutions to the system? Which one, if any? Pause it here and see if you can work this and get this by yourself. All right, so I'm going to start with this first one, x minus y. So we got negative 2 minus y, which is negative 1, equals negative 1. And let's see if, let me move down a little bit, 2 times negative x minus negative y equals negative 5. So all I'm doing is taking these 2 and plugging in these x and y values to see if they're true. So let's see. Negative 2 plus 1 equals negative 1. Is that true? That is true, actually. So this does work out. Does it work out for this one? Negative 4, negative is a plus. So that is negative 4 plus 1 is a negative 3. So this one does not work out, because it should have given me a negative 5. So negative 2, negative 1 is not a solution. Let's try with negative 4, negative 3. So if I put negative 4 here, let's try negative 4 minus a negative 3 equals negative 1. And 2 times negative 4 minus a negative 3 to equal negative 5. All right, so let's solve that. -4. Negative and negative is going to make a positive, so that's a +3. Does that give me -1? It does. -4 plus 3 does give me -1. So what about this one? -8, and this is +3 equal -5. Is that true? That's true also. So this is a solution to this system. And if you're dealing with linear equations, which we are, and we're only going to deal with that in Algebra 1, you're only going to have one solution because, well, actually, I take that back because I'm about to show you where you can have otherwise. But if the two lines are crossing, they're going to cross at that one point. But there is one case where that's not true. So let me show you that. All right, when we solve a system of linear equations represented by a graph with two lines in the same plane, there are three possible cases you can get, because I almost said there's one, you're only going to get 1 point, but there's three possible things you can get. You can get two lines crossing and forming one solution right here. In this case, the solution is what? 3, -2. 3, -2. That's our solution. That's the only point that they share where both the x and y values are going to be exact same for that point. Now, what else could you get? You could also get two lines like this, but they're never going to cross. So how many solutions are here? Good. 0. There's no solutions. So sometimes that's going to be the case, saying 0. So if I ask how many solutions are here, you're going to have to say 0, or there's no solutions. And there's one other. What if it's like this? Where's my other line? Well, they're literally right on top of each other. So they share every single point. So that's not right on the line. So all the points that you can imagine on this line are being shared. So this is going to make this an infinite number of solutions, because they share every single point. So that'd be an infinite number of solutions, 0 number of solutions, and one solution. All right, so with that in mind, let's solve this one. How would I solve this one by graphing? Graph these any way you feel comfortable. So you can graph it just the way the equations are here, or you could put them in slope-intercept form. Yes, I did say graphing. So you may have thought, calculator. Yep, obviously, I'm not going to use a calculator here because that's the obvious and easy choice. But yes, you could put that in the calculator, but I will do so later to show you how you can do that. All right, so let's start by graphing this one here. 2x plus y. 2x plus y equals 7. Now notice I'm not graphing it because it's not in a form that's graph friendly. It's not in slope-intercept form, and it's not in standard form in such a way that I can figure out the x-intercepts, or x and y-intercepts. So I'm going to solve for y by subtracting 2x over here and here. That way I can get my y by itself and see that my equation in slope-intercept form is this. Now I could do the same thing for this one, which I'm going to do. Let me change colors. And x minus 2y equals 6. I can get my y by itself by subtracting x. That leaves me -2y equals -x plus 6. Divide by -2. That leaves me y equals, this is going to be, this is a 1, so -1 over -2 is just 1/2 x. 6 over -2 is going to give me a -3. So graphing both of these, let's graph this one first since I already have my yellow out. It's at a -3. And I'm going up 1 over 2, up 1 over 2, up 1 over 2. And that's enough for me to get a line going. So let me draw a line here. And I got to try to keep it straight, right? Because that's the whole point. If you're graphing, if you're trying to solve by graphing, is that we actually want to try to keep these lines straight as we can. Now I would encourage you to make all the points. You know, I'm using a technology tool here, but I would keep going up 1 over 2, up 1 over 2. That's the most accurate way. So let me plot this one now. We're starting at 7 this time. And we're going -2. -2 is the same thing as -2 over 1. So I'm going to go down 2 to the right 1. Down 2 to the right 1, and down 2 to the right 1. Notice I'm actually going to manually do that this time because I can see I'm getting closer to that line, and I can now visually see right there is when they both cross. Down 2 over 1, and so I'm going to just draw a line even though I see exactly where they're going to be crossing. Right there, and there's my line. Bam. So the whole point was to find the point. Hey, no pun intended, right? So here's my point right here, 4, -1. 4, -1. That's my solution. That's the point that they both share. And you could check it by simply plugging in 4, -1 for x and y, 4 and -1 for y down here, and see that they both give you the exact same answer. So that's how we're going to solve using graphs. Let's do this one. So they both in slope-intercept form, which is fun because I don't have to move this, transform this into anything. I'm just going to plot it the way it is. So there's a 1 here going up to 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. So, and I can go down 2 over 1, down 2, down 2 over 1, down 2 over 1. All right, so now I got 4x minus 1. So I'm going to start at my -1 this time. And this time I'm going to apply a slope of 4. That's up 4 over 1. 1, 2, 3, 4 over 1. And there it is right there. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. All right, so 1, 2, 3, 4. So I'm going to make my line for this yellow one. That is not a good line at all. My goodness. Let's try that again. So we're going to make this line. And there it is. And I'm going to make my other line. I don't need to do this because you already see where they cross. And so we already made our point. It's right there. Right here at 1, 3. 1, 3. So that's my order pair. That's the solution. That's what we call the solution to this system, is where they cross. All right, let's go to our next one. So the last two were slope-intercept in slope-intercept form. What if we get in standard form? So we need to put it in slope-intercept form, and we've done this before. This first one, we're just going to subtract 3x on both sides. So that's going to leave me with -3x minus 1. For this one, we're going to subtract 2x, so that's going to be y equals -2x. There's nothing else over there. So when I graph those, it simply becomes, I got a 0 here. I'm graphing this yellow one, down 2 over 1, down 2 over 1, down 2, down 2 over 1, down 2 over 1, and then up 2, going the opposite way. And there we go. And now I could graph this one in blue. Start at -1 here. I'm going to go down 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. I'll notice they're not getting closer together, so I'm going the other way. 1, 2, 3 over 1, and there it is right there. Look at that, beautiful. 1, 2, 3 over 1, 1, 2, 3 over 1. All right, so let me go ahead and draw a line and connect these. There we go. And another line for this yellow. Bam. All right, so the point was to see where they cross, and we see that point right there at a -1, 2, -1, 2. So it's the same idea. We just have to do a little bit more work, getting it in a form that we can easily graph. All right, let's go to our next problem. Again, what if we have it in standard form? How would we do it? We could solve it using the intercepts, right? So we've talked about that before, but you could use the intercepts. And for this first one right here, I'm gonna say this is my yellow one. If x was 0, if that was 0, what would y have to be to get 2? That'd just be 2. And if y was 0, let's make that 0. That'd be x needs to be 2. So those would be my intercepts: 0, 2, 0, 2, and 2, 0. This is 2, 0, and 0, 2. And I will make that line. Is that right? Yeah, because I need it's a slope of 1, so that's what I'm looking for. So I'll stop it right there. And oh, that doesn't look pretty. All right, I'm going to finish my line here. Let's keep that slope the same. Bam, there we go. So now for this other one, I would make a table to look at my x and y intercepts. So if we're looking at this one now, if x was 0, what would I need to do for -y equals 4? What do I need to put here for y to get a +4? Well, this needs to be a -4, because minus a negative, or negative times a negative, is a positive. And if this was 0, if my y was 0, now I just have x equaling 4. So those are my 2 points: 0, -4, and 4, 0. Now connect those here, and it looks like that is a slope of 1 as well, so that should be easy to graph because it's going up 1 for 1. And let's see where they cross. Good. It's easy to see the crossing point right here, right? So that right in that spot. So that's 3, -1 is the solution for this one. So the only difference was I showed you how to use x-intercepts to put it in, to put the points on a line, and then we can find out the solutions. All right, so what do you do if you just have one like this? This is a horizontal line. So y equals 6 and 2x plus 3, y equals 12. So let's start by graphing y equals 6. I'm gonna make this one my yellow. I'm sorry, my blue. Y equals 6, and that's just gonna be a straight line horizontal going across like that. Now what about this next one? We'll make this our yellow. So I see this is in standard form, and because 2 and 3 are factors of 12, it's going to be easy for me to find the x and y intercepts. So I'm going to do that. So I'm going to say this is x, this is y. And what if x was 0? For x was 0, that'd be 2 times 0. 3 times what would give me 12? That's 4. If y was 0, 2 times what would give me 12? That'd be 6. So 0, 4. And 6, 0. I'm going to connect those dots. It looks like this is going, actually let me make sure I got the right slope. So this is going down 4 and up 6. So -4 over 6 reduces to -2 over 3. So it's going down 2 for every 3. So I know I can also write that as up 2 to the left 3. So up 2, 1, 2, 1, 2, 3. So I wanted to be careful there before I drew that line to make sure I got that point, so I counted, and I can see that's where the intersection is. Now for kicks and giggles, I'm going to go ahead and draw this line through here as best I can. Now that I know I got my point identified, I'm not too concerned about the rest of it. So this point is, what is that? -3, 6. -3, 6. So that's this point here. So that's my solution for this one. And this is really not an issue about graphing and finding a solution as much as it is knowing how to write the equations on the graph. Finding the solution is simple, but getting it in the point where we can easily graph it sometimes can be troublesome. So I want to go through different models there. All right, sometimes you're going to have a graph where there's infinite number of solutions. We mentioned that. Or sometimes no solutions. Let's work the next couple of problems to see what I'm talking about. So we can graph this first one pretty easily. I'm going to make this my yellow. So -3 here, and we're going up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, 1 over 2, and down 1 to the left 2, down to the left 2. So that's how we graph. So that should be pretty simple to you. For this one, it's not in the form where I can easily see it, but I can put it in, I can find the intercepts because I know that 1 and 2 are factors of 4. So I could just draw me a table here and say, well, if x is 0, then -2 times what would give me 4? That'd be -2. And if y was 0, this whole thing has gone away. You know, let's imagine this has gone away. So now I can see x equals 4. So that becomes pretty simple too. So those are my 2 points there. 0, -2. 0, -2. And 4, 0. 4, 0. So look at these lines, right? If I were to connect those, it becomes apparent that they are what? Parallel. So if I draw a line through this one, look at that. And it's never going to cross. Now you don't know for sure, right? So to be sure, let's solve this one for a slope. Actually, we could look at the slope right here, right? So down, we're going up 2 and up 4. So up 4. So what is 2 over 4? We simplify 2. That's 1/2. And so I see my slope is 1/2 here. My slope is 1/2 here. No wonder they're parallel. They have the same slope. They just have different y-intercepts. That's why they're never going to cross. All right, let's go to our next one. What about this one here? So my first one is 2x minus 3. I start with a minus 3 and go up 2 over 1, up 2, 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. There we go. So down 2 over 1, down 2 over 1, down 2 over 1. All right, so there's my line. Now what about this one here? This 6 and 3 aren't factors of 9, so I'm just going to put this in slope-intercept form. Plus it's going to help to see if the slopes are the same since we're in that discussion. So let's rewrite this one. I'll use blue. Negative 6x plus 3y equals negative 9. I want to get my y by itself, so I'm going to add 6x to both sides. That gives me 3y equals, we got 6x minus 9. Divide both sides by 3 to get my y by itself. That equals y, because this cancels. 6 divided by 3 is 2, so that gives me 2x. Negative 9 divided by 3 is negative 3. Negative 3. So here is my equation. Look, this is the same thing as this. So negative 6x plus 3y equals negative 9 is the same thing as y equals 2x minus 3. Why is that important? Because that's the same thing as our other equation. They're both the exact equation, just written in different forms. So if I were to graph this, you better be sure I'm going to get all the same exact points. So they're going to be right on top of each other, sharing the same lines. So if I were to draw this, let me change color. So if I'm going to try to give that idea. So you see these lines right on top, they're going to share every single point. Sometimes that happens. So what's the answer? Infinite number of solutions. They cross at every single point. You can't just pick one. Every point is going to be true in this case. All right, so let's sum it up. What we talked about, there's 3 different ways you're going to get solutions. One solution, no solution here with parallel lines, and infinite number of solutions. Let's look at application problems. So we talked before about how to set this up if you're trying to solve, if you're trying to just set up the system. But I want to go a step further now, a couple of steps further, and talk about solving them when you have a word problem. So let's look at a couple of problems. Sandra is making 10 quarts of punch. 10 quarts of punch from fruit juice and club soda. So those are my 2 things, right? I got quarts of punch from fruit juice and club soda. Let me look at the question. How many quarts of fruit juice and how many quarts of club soda? So those are the 2 things I'm looking at. I like to go straight to the question right here. So this part is a question. Before I even read it, I'm actually going there. So I'm going to identify, I'm going to go ahead and name those. That's my yellow piece. I'm going to name this my F. F for the number of quarts of fruit juice and number of quarts of, that's not, I want to use F for both of them. C for my club soda. So Sandra's making 10 quarts of punch from fruit juice and club soda. How many quarts of fruit juice and how many quarts of soda? So it's 10 quarts. So she needs total of 10. So F plus C is going to equal 10. Notice I'm not finishing the whole paragraph first. I'm just starting to piece a little bit at a time, because when you're given this much information at once, sometimes it can be tough to figure out where to start. Well, let's just take a little piece and start putting together what we know. The number of quarts of fruit juice is 4 times the number of quarts of club soda. So I know there's a relationship between the number of fruit juice and club soda. What did they say it was? The fruit juice is 4 times whatever the club soda is. Now the temptation is to put a 4 here, but that won't be correct. Why? Because that means if I had 1 quart, if I put a 1 here for C, or I'm sorry, 1 here for fruit juice, now how many quarts is that going to give me of club soda? Well, I have to multiply, right? 1 times 4 is 4. So now what I just said, well, there's 4 times as many club sodas, when actually there's 4, the fruit juice is 4 times. So I need to put the 4 in the other place. Now when I say there's 1 club soda, 1 times 4 is going to give me 4 fruit juices. So this is the situation I want to have set up here. All right, let's graph this. Let me see, how did I set this up? So let's make one of these our C and one of these are, so I'm gonna make this x-axis my C, and we'll make this our F. Let's get a table so we can kind of, actually for this one, it shouldn't be too hard. This is still in y equals 4x kind of mode, so I can already see what this is going to be like. So if I graph this first one, we'll use yellow. It'll be the same as y equals 4x. So my y-intercept would be 0, and I go up 4, 1, 2, 3, 4, and over 1. 1, 2, 3, 4, over 1, 1, 2, 3, and I'm out of space, so that's okay. 4 plus c. So let's solve this for f again. So let's solve this one for f. So it looks like y equals something. So that'll be, we'll subtract c on both sides to get this. So now we have a -1, but we're starting at 10. So our y-intercept's at 10, and I'm going to change color so we can see that this is my blue. I'll use this one for my blue. So we're looking at this portion right here. F equals -c, that's the -1, and we're starting at a y-intercept of 10. So we're going down 1 to the left one, I'm sorry, down 1 to the right one, down 1 to the right one. You can see right here is where they cross. Now if I can keep making those lines, and I'll go ahead and connect this one. And I can connect these yellow lines. But you can see clearly at this point, they have a solution. 2, 8. 2, 8 is my solution. So how many quarts of fruit juice? Well, 2 represented my x-axis, which is my C. So it's 2 cups of club soda and 8 cups of 8 quarts of fruit juice and 2 quarts of club soda. So that would be my solution there to answer that question. All right, how does this show up on the STAR test? So let's look at a few problems on the STAR test and how they showed up in the last few years. The line graphed on the grid represents the first of 2 equations in a system of linear equations. If the graph of the second equation in the system passes through, so this is one of the equations, but if the graph of the second equation, sometimes you got to keep reading like, okay, what are they asking? In the system passes through points -12, 20, and 4, 12. Which statement is true? Well, first of all, before we look at the answers, let's plot those 2 points and see which one looks true. So we got -12, 20, -12, and 20 is here. And 4, 12 is here. And you can kind of, just looking at those, you can see they look what? Parallel. So when I connect those, not that my line is perfect, but you can get a good idea. Now, to know for sure if they're parallel, and I would encourage you to do this, don't just look at it, is we have to identify the slope of each one. So let's do the one they gave us in the point form. So here, -12, 20, and 4, 12. So what's the slope here? The slope is going down 8 for every time it goes up 16. From -12 to 4 is 16. So what slope is that? That's going to be -8 over 16, which reduces to -1/2. Now, if this line is also -1/2, then hey, we got something. They're both parallel, and we already know what's going to happen there, but let's find out for sure. So let's identify 2 points. I got a point here, and I see a point here. So this is -4, 12, -4, 12, and this is 4, 8, 4, 8, and so this is going down 4 and up 8. So -4 over 8 reduces to -1/2, and look at this. They're both exactly the same slope. They have different y-intercepts, so they're never ever going to what? Cross. So this says there's one solution. Nope, there's not any solutions. They're never going to cross. Only so the only solution is this. Nope, there's no solutions. No solution. There is, and C sounds like the perfect answer. There is no solution. Infinite solutions? Nope. That's when the lines are right on top of one another. The only one that makes sense there is C. All right, you try this one. Which graph can be used to find a solution to this system of equations? Pause this and see if you can guess the right answer. F, H, G, or J. All right, so a couple of ways you can work this. One, like I said before, you can just put this in your calculator, or you can put these in slope-intercept form so you can easily see match up the graphs with the equations. I'm going to do both. I'm gonna put this in slope-intercept form. So let's do. Let me say that I'm using this for blue. 2x plus y equals -4. Subtracting 2x on both sides gives me y equals -2x minus 4. So that's one of my equations. So I'm going to go ahead and look for that one, and so I can eliminate anything else. So -4 and a slope of -2. So this, I don't have a -4 here, so I'm crossing this one out. And looks like I have one there. So that looks good so far. And they need to have a negative slope when they're going through. This is a negative, this is negative, and this is negative. So that looks good. Which ones? Actually, I don't want to do all that work finding all three. So let me go ahead and do the next equation to find out for sure what it is. So I'm going to change colors on this one. I'm going to use yellow. -3y equals 2x plus 12. And I'm going to divide by -3. Y equals 2 over -3. So that's -2/3 x. 12 divided by -3 is -4. So it looks like they both go through a y-intercept of -4. That is a telltale. So they both have a y-intercept of -4. Look at this. Y-intercept of -4. So that just made that easier. This one doesn't and this one doesn't. So I know my answer is F. Now I told you I would at least show you how to work this in the calculator and how to put this in, because that may be confusing for some of us. Like, how do we put that in? One's in standard form, another is in some form that has no name. You can use the relation feature on your calculator if you want, or put them both in slope-intercept form and graph them on your calculator if you can't see how to graph them by hand or you want to check it. So let me pull out my calculator and we'll see how to do that together. So I got my calculator out, and in your graph, so right, all I did was go to home screen and graph for those who don't know how to do that. So now it's in f of x equals something. Well, none of these are in f of x equals anything or y equals anything. So I need to put this into a form where I can put those in there. So I'm going to go to menu. Oh, by the way, there's another way to do this. I could just press delete on that x and I can go to relation. But I want to show you how to get there another way in case you don't remember. Graph entry and go to relation here. So relation just allows me to type it in just the way it is. So I'm just going to type 2x plus y equals -4, and I'm going to press enter and it's going to graph it, and I'm going to do the other one. So I'm going to press tab to pull it up again and do the other one. -3y equals 2x plus 12. So make sure I put that in right. It looks good. I'm going to press enter, and just a side note, notice that it says x comma y, so they can only understand x and y. If there's other variables there, you're going to have to change that on your paper, but you need to make sure it's x and y in the calculator. So I can see where they're graphing. I can see that these two graphs are the same graph. Until I just moved it. There we go. So I can see that these are the same two graphs as F, which I chose already. So I'm doubly, doubly, triply sure that this is the right answer. If I really want to be even more sure, you could analyze the graph for the point at which they cross, and I'm not going to do all that because the answer is more than clear. So let's get back to our problems. All right, so we got the next problem is here. The bus travels two different routes, the green route and the blue route. The routes are different lengths. So it looks like we're going to be comparing different lengths. On Monday, the bus traveled the green route 6 times and the blue route 5 times for a total distance of 52 miles. So we're looking at the two things are the green routes and the blue routes. So I'm just going to make this G and make this B. All right, so when I set this first equation up, and I don't even need to read the next one, it looks like they're going to set up the same way. Tuesday, the bus traveled green route 12 times and the blue route 13 times for a total of 119. So I can see that 6 times G, the length of G, is how long that bus traveled, because they want to know the length. And G is representing the length of the green route. So 6G, and I should have put a little g. I don't like to write that big number. So let's put a little g. It's getting in the way. So let's make that a little g. And I do want to do a big B, because B's look like sixes, and that gets confusing. All right, so 6 times for the green plus the blue route 5 times, so that's going to be 5 times B, is equal to 52 miles. And for my second equation, it's 12 times the green plus 13 times my B. That's 119. All right, so this is not a ideal problem for graphing, because it's kind of complicated. It's not small numbers and easy to graph. So I would have excluded this one, but since I already have it up, how would I work this if I want to graph it? I'm going to change these G and B into an X, so I can put it in my calculator a little bit better. So I'm going to make this 6X plus 5Y equals 52, and 12X plus 13B, oh sorry, 13Y, so that's why I'm changing it, equals 119. So now when I put in my calculator, it's a lot easier to do that. So I'm going to go to menu, make sure I change this to relation, and I'm going to put in, actually I could put it in as a standard. So let me show you how to do that. So I can go to standard and equation templates for a line and go to standard, since they're both in standard form. And I can type in 6, and for my Y, they got 5 in front of the Y. And for here, I have a 52. Press enter, and there's one line, and do the same thing. I'll press tab again. It's still in standard form, 12 and 13 and 119. All right, so there they are. So I can see that there's a cross here. I don't know what number that is. I can use menu and analyze my graph. Guess which one I'm gonna use? I'm looking for intersection. So I'm gonna click to the left and to the right of that point and look at what they tell me. They tell me that the one representing X is 4.5 and the one representing Y is 5. So what's the question? What's the length of the green mile? Well, the green mile is representing my G, so now I know that's 4.5. So that becomes simple. So this wasn't really a good ideal graphing question, because it has a decimal, and you can't graph decimals very well, so we stay away from that. But since it came up, I went ahead and showed you still how we can use the graph to solve that. A manager purchased a total of 21 coffee mugs and keychains. Each coffee mug costs $8.50. Each keychain costs $2.75. If the manager spent a total of $132.50, how many coffee mugs did he purchase? So we want to know how many coffee mugs did he purchase. So we got two things here, coffee mugs and keychains. I'm going to represent the coffee mugs with a M and the keychains with a C. So let's set this one up. We got a total of M plus, actually, you know what? I better, because I can see that I'm going to need to put this in the calculator as well. So I'm going to go ahead and use my X and Y and not have to change this again. So let's use X for mugs and Y for keychains. So that means X plus Y equals a total of 21. And the mugs, which are X, cost $8.50 each, so $8.50 each, plus the keychains of $2.75, and that's my Y, is a total of $132.50. And I'm going to use my graph to do that. So I'm going to clear my last screen. So now I have my calculator out. I've noticed that both of these are in standard form. X plus Y equals some number, X plus Y equals some number. So I'm again go to my standard form, graph entry, equation templates, line, and go to my standard right here. So 1 in front of my X here and 1 in front of my Y. So I'm just going to put a 1 there and a 1 in front of this Y. And that's 21 total. Pressing enter. I get a graph. Now I can't see the graph, but it's there. All right, now we're going to put that other equation in by pressing tab. We got 8.5 and 2.75 in front of the y and 132.50. Press enter. All right, so where's my answer? I don't see anything. So don't be dismayed. You know it's up there somewhere. It's just because our graph is limited. You can grab the screen and move it around by holding this middle button and just sliding your finger across the keypad there. Or you can grab the screen with your cursor by holding that button down on the screen and just sliding it over. So either way, I see that they cross right here, but what point is that? I'm going to analyze that point for intersection. I'm going to click to the left and right of that point, and there it is. So my x value is 13, y value is 8. What's the question? So let's go back to the question. How many coffee mugs is what we wanted to know. Coffee mugs are represented by my x, so it's clearly that is 13. So that's the answer that I will put there for my answer choice on that one. One wall inside a shoe store is used to display walking shoes and running shoes. There is 130 pairs of shoes. So that's the total. And I'm going to stop there because I see that my question is talking about how many pairs of walking shoes. So I know there's a total of, and I'm going to use this graph on my calculator again. So I'm going to call this x and this y. Walking shoes is x and the other is y. And I know there's a total of x plus y, 135 pairs. There are 1.5 times as many walking shoes. So let's say between walking shoes and running shoes, there's 1.5 as many pairs of walking shoes as there are running shoes. So there's more walking shoes. So I need to put a 1.5 on the running shoes. This is 1.5 many walking. Yeah. So I know that's it sounds counterintuitive because you're like, no, 1.5 goes on a big one. But when you start to place points in here, it'll make sense because 1.5 times, let's say you had one running shoe. Well, now you're going to have 1.5 times 1 to get your 1.5 walking shoe. So if you place points in here, you'll start to see that it makes more sense to put it 1.5 on that number. So let's erase that. These are my two equations that I want to use. So let's plug those in. And again, I'm using this calculator because it's tough to graph this by hand and they don't give us a graph to do that. So I'm going to use the graph from my calculator. So let's go back to my calculator and do just that. All right, now I'm going to place this graph in, or this system in here. Go to graph entry and I can go to line and I want standard because these are both, actually they're both not in standard form. So I'm gonna put 1 in standard form to show you that you can switch it up if you want to. So 1 and 1 is for my first equation and it equals 135. So that's my first one. What about this one? This is not in standard form. Now you could make it in standard form by subtracting 1.5x and setting it equal to 0. But let's say we didn't want to do that. So I could go back to menu, graph, and put it in relation and put anything I wanted to. X equals 1.5x or 1.5y. Press enter. So I know these are crossing somewhere and I'm going to slide up to see exactly where is this thing at. Now if I don't know, like this, I'm looking around and I can't find it. One, I want to make sure I put it in right. Sometimes I don't put the graph in correctly. But the other thing I want to do is go zoom and fit. So sometimes it'll give me an idea. So now I see 2 lines here. So I know that I'm in the right vicinity. So I'm going to slide it over. You can zoom out at this point, but it's easier for me on a computer to use my mouse to slide over. It may be easier for you to zoom out. But either way, there's my intersection. I'm going to analyze that intersection for here and click to the left and right. That is not the right one. So I want to analyze this intersection. Oh, it's different because I put it in, I have 2 different pieces in here, two different ways of looking at this equation. So I haven't had this before. So when I go to analyze, let me do that again. Intersection, it's asking me for the first corner. And what they're trying to do is get some kind of square. So I'm just going to click and I'm going to pull it out and see what happens. I make that square. You can see now where the intersection is. So it was a different way of doing it. So now it's 81, 54. So what's the question? So the question was, how many pairs of each shoe? Well, my X's are represented by walking shoes. So I can rewrite that in my, I can say that the X's are 81 and 54 and identify these with walking and running. So now before I look at my answer, I already know I'm looking for. I'm going to go straight down looking for 81 walking shoes. So this doesn't have 81. This doesn't even have an 81 in it. So now I want 81 pairs of walking shoes, not running. So that's what I want. And 54, I said 51. So 54 pairs of running shoes. So my answer is J. All right, let's do our last one here. And this should be pretty straightforward. All right, so in this one we have, there are 156 laptops and desktop computers in the lab. There are 8 more laptops than desktop computers. What's the total number of laptops? Well, let's call this, again, because I'm going to use my calculator, I'm going to just make one X. I'm going to make the X's laptops and the desktops Y. It doesn't matter which one you pick. Setting up my system, I know there's a total of 156. So when I add both of these, the number of laptops plus the number of desktops equals 156. What else do I know? I know there's 8 more laptops. So when we have this relationship X and Y, I like to start by doing that. There are 8 more laptops than desktops. So my desktops are here, and there's 8 more. So how do I represent that? All right, so I should put my 8. Now again, you got to think about this one. Actually over here. So this X represents my laptop. So what we're saying is that the laptops are the desktops plus 8. So this is how you want to write it. And now I want to set it up in my calculator. I'm going to do it the same way before. Now I could change this to be both in standard form, right? If you're comfortable doing that, you can just subtract 8 on both sides. Now they're both in standard form here. Or you can do standard form and a relation where you just put it in anyway. I'm going to put both in standard form just to make it easier. So I'm going to my calculator and we're going to go to relation, equation templates, line, and standard. And now I'm going to put in this one, 1x plus 1y is equal to 156. Press enter, and the other is 1x and negative 1, 1x and negative 1y is equal to 8. Press enter. So I'm looking for the lines. I know they're here somewhere. You can kind of move around if you want to, but I'm going to press menu and ask the calculator to go fit the graph. So go look for it, please. And they see it both here. Now I see where they're going to cross, and I just drag it over there, and there it is. I'm going to analyze this intersection, left and right, and there it is. So now I can see my X's are represented by my laptops are going to be 82 and 74. Now, does it make sense for what our situation was? Do they both add up to 156? Yes. Are there 8 more laptops than desktops? Yes. So we did set this up correctly. And now let's answer the question. What's the total number of laptops? Well, laptops are going to be 82. So that's the answer choice you would have wanted to write into your answer document. All right, that does it for us. That does everything. We've covered it all. Solving systems using the graph. Now, there's another ways you can use the calculator to solve this I'm familiar with. And in other videos, I'm going to show you that. But right now, I want to focus on how you can use the graph on paper or your calculator to solve these systems. Guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.